forgotten the things where we are. Is it the reason? Is it the long time? Please respond. Are you all there in the class? Okay. So we have discussed the square shaped arrangement of a feeder. Is it not? Did we discuss this thing or not? Please respond, ma'am. Did we discuss?
Yes, ma'am.
Yeah. Okay, fine. So what is the next type of arrangement? Is an hexagonal type of arrangement. The next type is a hexagonal type of arrangement. So please all of you copy this diagram. All of you please copy this diagram. All of you copy the diagram. Please inform me after you completing the diagram. Did all of you copy it? Did all of you completed, ma? Please respond. Are you there in the class or not?
Yes, ma'am.
Yeah, did you complete it or not? Just the thing what I am asking. What you are all doing?
Yes, ma'am.
For what you are saying, yes, ma? Did you complete it or not?
Completed, ma'am.
And that's the answer what I am expecting. I'm not asking any question from the subject. No, just I am asking whether to go to the next step or not. Okay, how much time I can wait for you? Okay, without your response. So what you can observe from this diagram, what you have understood from this diagram? Anyone? What you can understand? What is this one? Is it the substation? Is it the substation which is at the center located? And where the feeders are connected, where these are all the feeders. Okay, feeder 1, 2, 3, 4 and 5 and 6. All these are the feeders. Okay, so 6 feeders connected hexagonally. 6 feeders connected hexagonally. Is it the shape looking in the hexagonal form or not? Okay, so let us assume the length of the feeder. Let us assume the length of the feeder as L6. Let us assume the length of the feeder as L6. If you observe, this L6 indicates the length of the feeder. Is it not? L6 indicates the length of the feeder. The suffix 6 here indicating that as here it is a hexagonal arrangement and the total we are having a 6 feeders. So the length of the each feeder is represented as L6. Length of the each feeder is represented as L6. Did you understand the point? Okay, so what you are saying, how you are calculating the rating of the distribution of the transformer, because we know the expression, the rating of the distribution of a substation is determined by the voltage drop. Is it not? By calculating the voltage drop per unit value. By calculating the voltage drop per unit value. What is the standard formula we have derived for the voltage drop? What we have derived is, what is the expression? What is the expression, ma'am? Did we derive the expression for the percentage voltage drop or not? Did we derive?
Yes, ma'am.
What is the expression for that? What is the expression we have derived? L into K into. Are you having with you? Are you writing your notes or not? Are you writing your notes or not? Is it the expression what we have derived?
L into K into S. 3,
Yeah,
ma'am.
L into K into S. And this value of L depends upon the loading, depends upon the loading value or not, loading of the feeder or not. Okay, how many types of loadings of feeders are there? We have discussed in the 3 cases. The first one is uniformly loaded. The first one is uniformly loaded. Then what is the value of L? What is the value of L? L is equal to uniformly loaded. What is the value of L? What is the value of L for uniform loading? What is the value of L, ma? Is it L by 2 or not? L is equal to L by 2 or not? Please turn your pages. Did all of you copied that values or not?
Yes, ma'am.
What you all are doing? What you all are doing? Please all of you switch on your cameras once and show your notes. At least no one is responding. Did we discuss it about the uniform loading? What is the length of the uniform loading or not? Did we discuss or not?
Discuss, ma'am.
What is the value of L? L is equal to L by 2 or not?
L is equal to L by 2.
Yeah. When the load is of uniformly increasing, when the load is uniformly increasing, what is the value? When the load is
L equal to L, ma'am.
L is equal to L. Uniformly increasing. Uniformly increasing and decreasing.
2L by 3, ma'am.
Yeah, L is equal to 2L by 3. If it is decreasing, L is equal to L by 3.
L by 3.
Equally loaded on both the sides, L is equal to L. These are the cases we have discussed or not? So here the voltage drop expression is given as L into K into S, where K indicates the constant value and L depends upon the feeder and S is the rating of the system. Okay, S is the rating of the system. How you are calculating that value of S? S is equal to area covered by the feeder into load density. S is equal to A into D. Is it not? S is equal to A into D. Is it not? Okay, what is the unit for S? Is it kVA? What is the D? Load density. What is the load? D? It's a load density. So here, if you consider this hexagonal system, hexagonal feeder type of arrangement, okay, let us consider the first thing, area. Let us find the value of area. So A6 indicates that area covered by one of the feeder, It's not the total area of the substation or the rating of the, so just A6 indicates the area covered by the feeder, Why here we are writing the suffix 6? Because it's an hexagonal type of arrangement and we are having the 6 feeders, we represent the suffix as 6. So A6 is equal to, so let us consider, we have to consider the area. We have to consider the area, is it not? So here, this is the feeder. This is the feeder we are having. If you observe, this is the feeder or not? Okay, what is the length of this feeder? 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 Here it is visible or not? What is the value of the length of the feeder?
L, ma'am.
L or L6?
L6, ma'am.
Yeah, L6.
L6.
Okay, so let us consider the triangle. Okay, let us consider the triangle. Okay, so this is the triangle. Can I say this angle as 30 degrees? Can I say that angle as 30 degrees? If you consider this angle, what is the angle here? What is the total angle? What is the total angle here? Is it 360 degrees?
360 degrees.
Yeah.
ma'am.
So each angle is 60 degrees. Each angle here is 60 degrees.
Yes, ma'am.
Yes, ma'am.
In that we are considering only the half part. So what is the angle here? Is it 30 degrees?
Yes, ma'am. 30 degrees.
Yeah. So what is the length at this side? Is it L6? Is it L6? And here its angle is 90 degrees. So is it forming a right angle triangle or not? Is it forming a right angle triangle or not?
Yes, ma'am.
So I want this value. I want this value. What is the expression? Tan 30 is equal to? Tan 30 is equal to? What is the value? Opposite side by adjacent side. So x by. Can I write it as L6? What is the value of tan 30? What is the value of tan 30? What is the value of tan 30? 1 by root 3 is equal to x
1
by
by root
L6.
3.
So x is equal to L6 by root 3. So what is this distance? X is equal to L6 by root 3. So can I say from here to here, this distance is L6 by root 3? L6 by root 3? Is it clear? Is it clear? Is it clear, ma? So the next line?
Yes, ma'am.
Yeah, next line. So all of you note down this. All of you note down this. Let ఈ triangle draw చేసుకుని values వేయండి. So the length of the feeder is L6 and whereof the length of the base value is given as L6 by root 3. Did all of you copied?
Yes, ma'am.
Yeah, so we are having the sides. So what is the value of this side? What is the value of this side? From here to here, what is the value? Is it L6 by root 3 or not? Is it L6 by root 3 or not? Because same triangles, is it not?
Yes,
So
ma'am.
what is the expression for the area of a triangle? Half into what is the value of base? L6 by root 3 into height. Can I write it as
L6 by root 3.
Yeah. So how much area is covered by this feeder? Is it 2 times of the triangle or not? The area covered. So if this is the feeder, what is the area covered? Is this the area covered by this feeder? Is this the area covered by this feeder? Is it not? So can I write it as 2 into okay, 2 times. Okay, 2 times of half into L6 by root 3 into L6. Can I write like this? So from this 2 get cancelled and what is the area? L6 square by root 3. Is it the area covered by the feeder? Is it the area covered by the feeder? Please respond, ma. Did you understand the point?
Yes, ma'am.
Yes, ma'am.
Okay, so what I'm saying is here, okay, you have calculated, okay, see, the length of the feeder, here I am drawing again, this length is L6 and this length we got it as L6 by root 3 and this will be also L6 by root 3. So what is the total area covered by this means? Is it the 2 times of the triangles or not? Okay, so what I am writing, what is the area of the triangle? Half into base into height. Half into base into height. So here we are having a 2 times. So I am writing 2 into half into base into height. So what is the value? L6 square by root 3. What is the area covered by a single feeder? Is the area of the substation or the area covered by the single feeder? Is it the area covered by the single feeder or the total area covered by the substation?
Single feeder, ma'am.
Yeah, what is the area covered by the single feeder? A6 is equal to L6 square by root 3. L6 square by root 3. Then S6 is equal to, what is the value? S6 is equal to, can I write it as L6 square by root 3 into d kVA? Can I write as S6 is equal to L6 square by root 3 into d kVA? Why? Because S is equal to A into D. Why? Because S is equal to A into D. Did you got my point? Did you got my point? Then,
Yes, ma'am.
what is the percentage voltage drop per unit value? What is the percentage drop per unit value? What is the expression? What is the expression? Percentage voltage drop is equal to L into K into S. So can I write it as S6? Because we are considering the hexagonal arrangement. We are considering the hexagonal arrangement. So that is equal to L into K into, what is the value of S6? L6 square by root 3 into D kVA. Is it not? Is it not? Do you understand? What about this L? What about this L? It depends upon the feeder loading. It depends upon the feeder loading. For a while, let us consider that load is uniformly increasing. That the load is uniformly increasing. Then what is the value? What is the value of L? Can I write it as 2 into L6 by 3? Can I write it as 2 into L6 by 3 into K into L6 square by root 3 into D? Is it the value? What, ma? Did you understand? That is equal to 2 by 3 root 3 into K into L6 cube into D. Is it the value? Please respond. So
Yes,
please
ma'am.
calculate this value. Please calculate this value. What is in the fractional form? In the decimal form? What is the value? What is the value? Are you all having the calculus with you or not? What is the value, ma? Is that much time required to calculate the value? Are you all there?
.38, ma'am.
So 0.38 K into D into L6 cube. Okay, for suppose if the value is uniformly decreasing, if the value is uniformly decreasing, that means the load is uniformly decreasing, then which value will you substitute for L? Which value will we substitute for L? L is equal to decreasing load.
L by 3.
Yeah, we have to substitute as L6 by 3 into K into D into L6 square by root 3 is equal. This will gives you the uniformly decreasing load. If it is uniformly loaded, if the line is uniformly loaded or the feeder is uniformly loaded, then what is the value of L? Can I write it as L is equal L6 by 2?
2.
Yeah, in this way you will calculate the voltage drop of each and every feeder. So the voltage drop of each and every feeder leads to the rating of an total substation. In this way, if you calculate it for the 6 feeders, the total rating of these 6 feeders will lead to the total rating of the distribution substation. Is it not? Is it not? Is it clear? Did all of you understood about the hexagonal type of arrangement? Did all of you understood
Yes,
about
ma'am.
Yes, ma'am.
Yeah. Please, all of you note down the expression. What is the area for the hexagonal arrangement? Area of the feeder. Area of the feeder A6 is equal to. Area of the feeder A6 is equal to. What is the expression? A6 is equal to L6 square by root 3.
3.
L6 square by root 3. Did all of you copied? Can I clear the screen? Can I move to the next one?
Yes, ma'am.
Yes, ma'am.
Okay. The next one is with n number of feeders, because we cannot say that. We cannot say exactly that. Okay, we'll have a 4 number of feeders or a 6 number of feeders. Okay, before the extension time, at the establishment time, we may plan for the 4 feeders, but the demand may increase. Then we need to increase the value of the feeders. Then what the amount of the increase of the feeders is to be unknown. Okay, it may be a 2 or a 3 or a 4. In that case, is the fixed value of arrangement of 4 or that is square or hexagonal workouts? No, because so here if you derive the expression with n number of feeders, we can apply for any number, either for a 2, 4 or a 6 or a 3 or a 2 or any one. So we are deriving the expression for n number of feeders, So substation service area with n number of feeders, the n value may vary. Is it not? If it is n is equal to 4, it represents a square shape of arrangement. If n is equal to 6, we can consider it as a hexagonal. And this is the case here. We are not saying that the arrangement is either a hexagonal shape or an square shape, because here we are considering the value as theta. And theta may vary, For suppose, if you consider the hexagonal system, what you are saying, the angle theta is equal to 60 degrees from feeder to feeder. Is it not? What we have discussed, is it not? The angle here is 60 degrees or not? The angle between 2 feeders in hexagonal arrangement is 60 degrees or not? What, ma? What is the value between these two? Is it 60 degrees? 360 divided by 60. Is it 60 degrees or not? In the hexagonal arrangement is the value. Okay. So if you consider what is the angle here? Is it 60 degrees or not? Okay.
60
If
degrees.
you are going with an hexagonal arrangement, then what is the angle? It's a fixed value. It is to be 60 degrees. If here it is a square shaped of arrangement, then what about the angle? Then 360 divided by 4. So then what is the angle? Is it 90 degrees?
Yes, ma'am.
Yeah. So here what you are saying is, if the arrangement is a square, then the angle is to be definitely it's a 90 degrees. And if it is a square type, hexagonal type of arrangement, then the angle is to be 60 degree. If you observe here, are you saying that the value is a fixed value, either it an angle 60 or a 90 and so on? No, we are considering that the angle may be theta. The angle may be theta. We are considering here the angle as theta, and this value of theta, then this value of theta changes with an n number of feeder count, changes with an feeder count. For suppose if n is equal to 10, if n is equal to 10, what is the angle between feeder to feeder? If n is equal to 10, what is the angle between feeder to feeder? What is the total angle? What is the total angle? Is it 360 degrees or not? Is it 360 degrees or not? What my total angle here? Total angle covered by the substation 360 degrees.
ma'am.
If you are having 10 number of feeders, that is n is equal to 10. If you are having n is equal to 10, then the angle between feeder to feeder, the theta value is equal to what happens? 360 degrees divided by 10. So what is the angle? 36 degrees. Is it not?
36 degrees.
Yeah. In the same way, if n is equal to 12, then what is the angle? 360 degrees by 12. Okay. If the n is equal to 36 feeders, then what is the angle? Theta is equal to 360 by 30 degrees. So depending upon the number of feeders, the theta value varies. Here, if you observe this diagram, out of n number of feeders, here we are showing the area covered by a single feeder. A, B indicates the feeder main. In this way, this is the first feeder. In this way, we are having n number of feeders. Where the angle covered, or the area covered by this is given as theta plus theta, that is 2 theta. So the remaining angle will be, can I write it as n minus 1 into 2 theta? N minus 1 into 2 theta. The total area covered by the total angle covered by the other feathers as n minus 1 into 2 theta. Here the total angle will be, the area covered by the first feeder is 2 theta. The remaining feeders will be, out of n we are removing the 1. The remaining feeders count is it n minus 1? And the angle covered by that n minus 1 is 2 theta, because each feeder is making an angle of 2 theta. Is it clear, ma? How you got this value as n minus 1 into 2 theta? If you observe the arrow marks from here to here, what is showing? The remaining angle other than this. So the remaining angle other than this is n minus 1 into 2 theta. Did you got my point?
Yes, ma'am.
Did you got my point? Yeah. So here in this feeder, in this area, okay, of the feeder, first feeder, we are considering a part of the section. With an area of dA, which is having a distance of dx, the sectional distance is, sectional length is dx, placed at a distance of x from the substation. Is it clear? Here in this service area, okay, I am considering a part of section of feeder with a length of dx, placed at a distance of x from the substation. Okay, and the total length of the feeder from the substation to the consumer is considered as ln, and the vertical distance of this section, is given as y. Did you got my point? Did you understood the diagram? What this representing? All of you understood? Is it clear, ma?
Yes, ma'am.
Yeah, please all of you copy down. All of you copied? All of you completed, ma?
Yes, ma'am.
Yeah. So here, so what the thing what you have to find? The same percentage voltage drop. What is the thing what we have to find? Percentage voltage drop. What is the formula? L is L into K into S. Is it the formula? Okay. So where S is given as S is equal to, okay, what is the formula? S is equal to area covered by the service feeder into load density, Is it not? Is it not? Is it the formulas or not? Is the same thing
Yes, ma'am.
what you are discussing from the square type of arrangement to hexagonal type of arrangement, and here also the formula remains the same. There will be no change in the formula. So here if you are, here we are considering a part of the section. So can I write a part of the section ds, the KVA rating of the section ds is equal to dA into capital D? Can I write like this? Is there any wrong if I write like this? Okay, because we are finding out the KVA rating of this section, a part of the section. So ds is equal to dA into D. What is the area covered by? What is the area covered by this section? What is the area covered by this section? So what is the value for the dA? What is the value for dA? Can I write it as dA is equal to dx into y? Can I write dA is equal to dx into y? Is there any wrong if I write like this? Is there any wrong? dA is equal to dx into y. Is it right or wrong? Okay. So from this, can I write tan theta is equal to, from the triangle, can I write tan theta is equal to y by x plus dx? Consider this triangle. So tan theta is equal to opposite side. What is the value of the opposite side? Y. And the total length of this up to this section is x plus dx or not? So from this, can I write y is equal to x plus dx into tan theta? Y is equal to x plus dx into tan theta. Is it right?
Yes, ma'am.
Is it right? Okay. So then, on substituting, okay, here dx, can I say this dx as a minor or a minor section or a minimum section of the total feeder? Of a total feeder, can I write like this? Okay. Is it the minor section or a minimum section or not? What is the length? Total length is ln. Out of which we are considering only a part of section. Is it not? Are you following or not? So dA is equal to, in place of y, can I write it as x into tan theta? What, ma? Can I write it as x into tan theta? Are you following or not? Or else?
Yes, ma'am.
So dA is equal to, okay, is a part of section. Area is equal to, can I write it as x is equal to 0 to ln of dA? Can I write like this? Is there any wrong? That means the total area is from x0 to ln or not? ln or not? For this, for this, I am writing as x is equal to 0 to ln, x is equal to 0 to ln, okay, of dA. What is the value of dA? What is the value of dA? What is the value of dA? Is it x into y? So, are you following or not? Is it x into y or not? If you want to extend. So, here if you observe that x into y is equal to, can I write it as x square into tan theta? X square into tan theta. Did you got my point? X into y is equal to x square into tan theta or not? On substituting, what is this x? What is it, this x? If you want to compare the total area, can I replace the x value as ln square into tan theta? Is there any wrong? Is there any wrong? If it is a part of the section, the length is x plus dx into y. Very good. For if you are finding the total area, this x plus dx will be extended up to ln. Is it not? Is it not? Okay. So ln into y. Ln into y. What is the value of y? What is the value of y? X plus dx into tan theta. Here x plus dx for the total area, can I write it as ln? So ln into ln square into tan theta. So area covered by the total surface area is ln square into tan theta. Did you understand this point or not? Did all of you follow this point? Why the area is ln square into tan theta? Did you understood this point or not, ma'am?
Understand, ma'am.
Yeah, A is equal to ln square into theta. So we got the area. Then S is equal to, can I write it as S is equal to Sn? Because n number of feeders. So An into D. What is the value of An? Can I write it as ln square into tan theta into D? Ln square into tan theta into D. From this, voltage drop is equal to, voltage drop for n number of feeders is equal to L into K into ln square into tan theta into D. For suppose if you are considering uniformly increasing load, then this value of L is equal to 2L by 3. So 2 by 3 ln into K into ln square into D into tan theta. From this, we can write it as 2 by 3 into K into D into ln cube into tan theta. Is it the expression or not? Is it the expression or not? Is it the expression or not? Is it the expression? So from this, what is the value of tan theta? What is the value of tan theta? Can I write n into 2 theta is equal to 360 degrees? Is there any wrong if I write like this? Total angle is 360 degrees. How many feeders are connected? N number of feeders into 2 theta. So from this, theta is equal to 360 degrees by 2n. So here 2 by 3 into k into d into ln cube into tan of 360 degrees by 2n. So this is the formula for the rating of the transformer, rating of the service substation when n number of feeders are connected. Okay, if it is uniformly loading, then what is the value of L? What is the value of L? L is equal to, what is the value of L here? Can I write it as L is equal to L by 2? Can I write it as L is equal to L by 2? Here this value depends upon, the nature of feeder loading. This value depends upon the nature of feeder loading. Did all of you got this point? Did all of you understood this point?
Yes, ma'am.
Yeah. Did all of you understood about the service area of primary feeders? How to calculate the service area for n number of primary feeders? Is it clear? Okay, for suppose we are having 4 feeders. What is the value of n? What is the value of n? What is the value of n? Is it 4 or not?
Yes, ma'am.
Then what is the angle of theta? What is the angle of theta? 360 by 8. What is the angle?
45, ma'am.
45 degrees. If you are having 4 feeders, the angle covered is 45 degrees. If you are having 6 feeders, if you are having 6 feeders, if you are having 6 feeders,
60, ma'am.
yeah, 60 degrees. So, if is it matching with the thing what you have discussed earlier? What you have said hexagonally 90 degrees. Is it not? Hexagonally 90 degrees. Here theta is only a part of the section. For the distance between feeder to feeder, is it 90 degrees or not? Is it 90 degrees or not? In the similar way, here 6 feeders in the sense hexagonal. Here 60 degrees. So the feeder to feeder angle will be, is it 120 degrees or not? Do you understand the point? So here, if you calculate the value, if you calculate the rating for n number of primary feeders, it is applicable to all type of arrangements. It is applicable to all type of arrangements. Is it clear? Did all of you understood this point? Please respond, man. Did all of you understood?
Yes, ma'am.
Okay, we'll continue in the next class and we'll wind up this class. Okay.
Good morning, students. Good morning, students.
Good morning, ma'am.
Yes, ma'am. How are you all? Students, talking with you only. How are you all?
Fine, madam.
Ain't Latif, voice dull ga undi. I hope you all are safe. I think. Students.